Well, hi, good morning, and thank you so much for joining me in my shop here. Today I'm going to be messing around with antennas, but first I'm going to look into a comment that was made by one of you about the capacitor down here and where it should go. Apparently I may have put it on the wrong pin. Right now it's disconnected completely. Didn't seem to have much impact on anything anyway. But I figure if I give this guy a pretty good rub down right at the start, he's going to leave me alone. That's my theory here. I don't know if that's a good theory or not. Is that a good theory? And you see he's on my keyboard, but I've craftily turned it off. And I always wondered why would a keyboard have an on-off switch? Well, now I know why. This is a good way to start the day, considering what's happening in the world. Let's not consider what's happening in the world. Lots of other people are doing that. We don't need to do that. No one wants to operate the radio. What was that? What's that? Let's get working on the radio, he said. That's what that is. Okay, so even with the cat here, I can start dealing with the situation down here. Now the comment, I'm going to put it up on my own screen here. Looking at those pictures of the 6F5 base, the 100 picofarad that should be connected to pin 4 is actually connected to pin 5, which has no internal connection. And this is from someone who goes by the name Jim Knowles, 9634. Well, maybe Jim Knowles knows, but the Jim here doesn't seem to know what Jim Knowles knows. Okay. Now it's not connected to anything right now, but I thought the pins were tied together in this tube, and it didn't really matter which of those pins you put it on. You're kind of in the way, cat. You know that? That's right, Mr. Kitty. Oh. Got left my television playing in the other room there. Okay, let's take a closer look at the situation here. It was difficult for me to spot the key, the tube key. Don't push it over. Don't push it over now. I'd show you what he's doing, but it's a little tough because he's like right here at the camera. Bert, what are you doing today? What do you got in mind? What was that? I didn't quite catch what he said there. Okay, I think we're going to want to look with a closer up camera here. And we'll see what we can see there. And I think I may have a focus problem, but let's just check it out and see what happens. Okay. Wow, every time I look at my soldering there, it freaks me out. You can't see that so clearly with the eyeball. So this capacitor here is not connected. This is the 100. And I can see the pin key very clearly now down there. So let's count. Let me get this out of the way here. 1, 2, 3. So pin 4 is right here. See, it's tied to pin 5. What is this loose looking wire here? Just a sec. Right, my cat's trying to escape. Here. Out the door. This way. There you go. Okay. He's on his way to create havoc in other parts of the house. So again, the comment, let's just read it again. It should be connected to pin 4, which is the plate. It's actually connected to pin 5. Okay, so counting the pins here, 1, 2, 3, 4. Yeah, I see what they've done. They've just tied 4 to 5 with a jumper here, and then utilize the 2 terminals for an awful lot of connections. Boy, that soldering just looks it's like terrible. But come on, focus. Nothing's loose. What's that one more? This one here. That's the worst soldered one, but it's also soldered in there. I think I'm going to resolder that stuff. So I can bring this capacitor over and tie it anywhere in there. And there you are. It is where it's supposed to be on the plate, but as we heard, there was no audible effect. You couldn't really hear any effect. And maybe you can't, because it is supposed to be quelling, either high, well, that looks great, either high frequencies like our radio frequencies, or harmonics that are beyond your hearing. Yeah, so I'm gonna whip a pile of solder on this. If I just throw piles of solder on there, I think we'll be okay. But I don't think it's helped with the tone control. Tone control situation. I just think there's the tone control capacitor is right up here. That thing right there. I think it's just too big. It's a .005. That's what it calls for on the. I don't know what to think. I don't know what to think about it. Come to think of it. Okay, so let's stick with what I'm doing, which is soldering that connection. Okay, and we'll get that done. Then we're going to get back to antenna fun today. Have some fun with this radio. Before we get going on the antenna, I'm going to sketch some diagrams here and try to make it apparent what the terminals back here are all about. You see there's 4 terminals, red, black, black, and red. Why so many terminals? Why does a radio need so many antennas? What is going on? So in this, let's not deal with this radio. This is a fairly advanced radio. Let's talk about a real simple radio, like one, like it might have been a 5-tube clock radio or something like that back in the 50s. How would they do it? I'm going to draw the first vacuum tube over here, first amplifier. Okay, and you may not know how a vacuum tube works, and that's okay. The key thing is this line I'm drawing now. This is called the grid, and this controls the operation of the tube. So the voltage applied to the grid has an effect on how much current flows out this way into the radio. This goes into the rest of the radio here. So put a signal here, get a signal there. Put a weak signal here, get a strong signal there. That's the amplifying effect of the tube. How do you get the signal here? Lots of challenges with that. But very simply, in some radios, I'll draw the antenna. They often draw an antenna like this. That's an outdoor antenna of some sort. In some radios, there's a screw on the back of the radio you hook it up to, or maybe a wire hanging out, and this goes essentially straight to the grid. So basically, the antenna driving the grid, causing the amplification of the signal to come out here. You have a weak signal from the antenna, stronger signal here. Maybe you want to run it through the same thing again and boost it even more with another tube here. It's up to the radio designer how he wants to do it. Now there's a lot more to this than I'm explaining, but just very simply. So this would be a real simple connection, but there's some problems here with this connecting. This very simple way of doing it. There are a number of problems, so you can improve this. So one way to improve it is to make the connection like this. Instead of a direct connection, you can use a transformer. So we put a transformer here. Put a transformer here. Yeah, secondaries here. Now, we got to do something with the ends of these. So, without going into explanation for why it makes sense, it would make sense to attach this to the chassis of the radio, or let's just call it ground. That's a terrible use of the word ground, but you could do that. Now, I mean, this is a very simple diagram here, so there's lots more going on in a radio than this. And then this one, you could also attached to the ground. Only in this case, it might not be the chassis. You might actually have a ground rod outside the house. And then you can see the antenna and this coil and this ground, they really are quite separate from the rest of the radio. They're really not in direct contact. This is very common. Very, very common way of doing it. There's lots of advantages from this. There's some impedance matching and other things that can be done with this transformer, depending upon the number of turns you put on it. You can even make this transformer really boost its effect by sticking capacitors out here with this. And if you do this, you can make this resonant, and make this resonant, which means it's tuned to a certain frequency. Of course, that might have some limitations, right? I mean, if this is all tuned up really sharp, then when you're listening to a station, you're only going to hear the ones that are in the range of the tuning of this. So maybe this isn't the best idea. Maybe this. Maybe get rid. Maybe just like that, or maybe get rid of this. Or maybe have more than one coil. Maybe a transformer. Maybe you have a transformer here that's designed to work for the low frequency stuff. Excuse me, the AM radio. And maybe have another transformer down here. I'm just going to draw it like this. There's all kinds of ways of doing this. Many radios are quite different. Draw the secondary. Maybe this one's designed for the AM radio and this one's designed for the shortwave radio. They're quite different. The frequencies are way different. Shortwave is sometimes 15 times the frequency of this. So this could be quite different. This might be a big fat thing. This might be a little skinny guy. I don't know. We'd have to look at the radio and see what was done. In some cases, with radios that have multiple bands, they have more of these yet. They have even more of these coils tuned to the individual bands. What are you going to do? Hook a wire all up in here and have them? No. They get a big band switch, like this radio has a band switch on it. And the band switch has lots of little switches. And you can actually switch. You can switch the antenna from here to here to here. And so as you turn the band switch and select different bands, you could be selecting different transformers at the same time. I believe, we're going to look at the schematic in this radio in a minute, but I believe this one has this arrangement where it has the AM transformer and a shortwave transformer. I believe that's how they've done it. And the band switch, in some curious way, switches the antenna signal between these two. Sometimes they just let it go through both all the time. And what's happening is one of them is tuned to the area you're listening to, like this might be the AM thing, so it's tuned to the AM band. So when you have an AM radio signal, like maybe 1010, CFRB or something like that coming in, it finds its way through this real easily, but it can't get through this one. This one's tuned for something else. Then later, when you've switched the bands and tuned the radio way up to some shortwave frequency, it comes down through here, but it can't get through this. But this one's tuned for it, so it goes through here. I didn't show it, but this wire would basically be coming up, up like this, maybe through the band switch, so it's switching which one it picks off. So that's kind of what's going on in the front end of these radios. They have transformers. They may not have a transformer. They have multiple transformers. They may not have multiple transformers. It all depends upon the engineer and the design that he wanted for his radio that he was working on. Of course, the more of these you put in, the more expensive the radio becomes, the more difficult to build, the more involved in tuning it up afterwards. The costs go up and up and up. More and more parts, more and more cost. But better and better radio, mostly. Let's look at the schematic now, and we'll just consider all this stuff and see it for real on the schematic. Okay, so here's the whole schematic, and the part we're talking about is this part here, including the first tube amplifier there, and up in these terminals, this whole area here. Let's zoom in on it so get a better look at it. So let's start with the shortwave antenna. So this A3 is the shortwave antenna. Connect the counterpoise to A3. Counterpoise. That's an unusual word. You don't see much in these. Connect the counterpoise. Okay. Why are they using this word counterpoise? I may have been wrong about how this operates. I didn't see this note until just now. Range switch view from front shown in A band position. This is all for the local oscillator. Well, let's study it a bit more here. This terminal comes all the way through basically to ground. You know, I don't understand what this blue terminal is. Now, I tried this as an antenna. I got nothing. And this capacitor is currently missing in the arrangement. Counterpoise, eh? Okay, well, let's take a look at the A1, A2. So suppose you hook up to either A1 or A2 a long wire that's hanging in your backyard. So we just have one piece of wire coming over. And you hook it up, let's say, to A1 here. So they've got this twisted, and that's okay. So A1 will follow around, comes here, go through this transformer coil, and then head down this way to encounter the chassis through this capacitor, which I removed right now. Okay. Somebody just opened my door. Look at that. Bert has returned here. Okay. Now, looking on. So see, there's another coil down here. So my assumption was this would be the broadcast coil. They've arranged it to be used with a loop antenna, which I haven't discussed yet. So this would be the shortwave transformer. And although pictorially they've got these secondaries spread out here, in reality they're probably not spread out. They're all probably closely coupled, if you like, to this. Wow, this is a little more complicated than I thought, and I hate these switches because they're very hard to understand what is going on with them. You have to study the shape here and think in your head, okay, if you snap it one over, then this goes here and that goes there. So I try to avoid thinking too hard about these, unless I'm really forced into it. This part's easy. You can see the signal path going to the grid. This is the grid connection here. The cap on the top of the tube is pictured right here. It goes into the grid. You don't have to worry about these other grids. So we know that this long contact's always in contact with this piece of copper here, no matter how you rotate it. What's going on there? My screen started jumping around. In some cases this variable capacitor gets switched in other cases not. This is shown in the broadcast band position. So see, this is not engaged. What's engaged right now? Hey, let's follow it. We can do that. If this is the broadcast position, this is what's engaged. What? Coming down here? Well, I got this totally misunderstood. This is now starting to look like the broadcast coil. Oh my gosh, I know. C3. So there'll be some instructions on when C3 needs to be adjusted. Actually, I think it's C2 here. What's that say? 11 to 500. So this is the tuning capacitor, the big one with all the plates, and this is a little adjustment here. 3 to 30 picofarads. C3. Let's see C3. Let's look at the alignment instructions and when C3 gets adjusted. And where are those instructions? Here we are. Okay, when does C3? Here's C3 here. It gets adjusted for the broadcast band. So C3 is related to the broadcast band. Well, I got this totally misunderstood, but that's why I'm doing this. You think I'm explaining it to you, but actually I'm explaining it to me. So this is broadcast down here. So what's happening with this? Is this coil interacting at all? When does this coil get interacted? Oh, it says right here, 19 meters, 25 meters, 31 meters, 49 meters. And of course, broadcast, but I didn't write it here. Okay, L6, L7. Now you can see how differently this coil is treated from these three. These three all seem to be kind of wired the same way. This one's got all this other schmozzle here. So clear, yeah. So I had it totally backwards. So connecting the loop antenna here, which I haven't explained again, would energize this part of the transformer. Right, like this would be what's operating. The other part's down here. Maybe this is just pictorial and it really doesn't represent how things really are. And physically, this is close to here, but they showed this one close to there. I don't know. How else can we figure this out? When do you adjust this one? C1, which seems to affect everything. My cat tried to get in, now he's trying to get out. C1. This is the one that's not listed. This is the one that exists in the radio but is not in the table here. C1, yeah, it's this thing here, which I never adjusted. Because it says when you should adjust it. And C1 looks like kind of like a general adjustment for the whole thing. I don't know. Huh. Boy, oh boy. Well, the fact is, I'm not figuring this out. I really am. I'm really caught on this being the AM loop antenna part, but I'm caught on this being the AM part or transformer. I don't know. The reason I want to understand this is because when I'm hooking up antennas here, I'm not getting the result I expect, especially with this wire. Let's find out more about this counterpoise. So that's an unusual word to use there. Connect the counterpoise. Now it could be they're talking about a little piece of wire running around inside the cabinet of the radio, and that may be the counterpoise. What do you say we look this word up and see what... hey, I know what. Let's call on her.
Hey, Jim.
I've got a question about an old radio and the antenna transformer system in it.
Ah, gotcha. So what's the question?
I forgot my question. What was the question? I forgot the question. Give me a second here to figure out what I was going to ask you.
Uh-huh.
Oh my gosh, I can't believe I actually forgot what I was going to ask. Okay, I'll come back later. You don't have to worry about being rude to the machine, right? How did I forget what I was going to ask? It's probably because there's a cat right above me. There he goes on the microphone. Oh my gosh, I'm going to take a little break here because clearly my brain's no longer working. And look at my cat. Okay, kitty. Let's go. You know what it is? I haven't drank enough coffee yet. Here goes the microphone, number 2. It's the routine. It's the morning microphone routine here. Oh, for crying out loud. Can you please? No, 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 no. Don't do that. You know what would be a lot more fun if you came with me? Come with me out the door here. Come on. Come on out here. Come on, smart one. Leave that alone. It didn't work. Can you? This is probably pretty interesting on the video what it sounds like. You've got to come down. You've got to come over here. Like, look at this thing. Look at this thing. Isn't that weird? Look at that. Look. Little piano. He's fully distracted. A small piano. Important things to have here. Come on now. Let's go. Let's go. Here we go. No, 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 no. No, no, no. Crap it like that. Okay. See this thing? I'm going to throw this thing. See this? Watch. Now don't go crazy. Hey, watch it. Watch. There, go. There. Go get it. Go get it. Okay, I'm bringing you down. That's enough. I've had it with you. That's enough. You're coming down. You're coming. You're coming. How come you got so many legs? You got too many legs. You're coming down. Oh, ooh. That was a dangerous maneuver, I have to admit. But success. Okay, now look at him. A lot of you like cats, so I don't mind showing my cats here. Especially this guy here. Bert the Wonder Cat. Oh yes, last night we had excitement. Our other cat, our 10-year-old black cat, who goes outside. It's time to come in. I open the door and the cat comes walking in and stops and drops a mouse on the floor of our kitchen, which immediately takes off into the house. So we had a mouse in the house. Bert here got it. Bert here managed, he's a mouser. He managed to get the mouse. But in the end I got the mouse. I got the mouse and threw him out of the house. So lucky mouse, because he wouldn't have lasted in here with 3 cats. Yeah, and you'd think mice are really smart about, no, they're not particularly smart, it seems. He could have done a lot better job hiding than he did. Okay. How much you want to bet that mouse will be back in our house at some point? What are you doing? Oh my gosh. Oh, oh. Going down. Okay, we're on our way. Coffee break time has come. I told you the mouse story. Good story. Not for the mouse. I'm back at my shop here because I remember what it was I was going to ask the co-pilot, but it was the word counterpoise. But in the meantime, I was out getting my coffee ready and walking through my house when I look down on the brown rug that I'm standing on and I see a smear of cat barf, which I stepped in and proceeded to march around the house with unknowingly cat barf on the bottom of my slipper. So consequently, I am in here in sock feet, which is not a good idea in a shop like this. And that's the thing about cats. Cats, very fastidious animals. Cleaning themselves all the time, cleaning each other, using a litter box, very careful about that, covering everything up, and just taking care of all that kind of stuff. Except when it comes to barfing, right here will do. Blah! They barf anywhere they are. Anywhere they're standing is perfectly fine for barfing. Everything else, they want to be clean and neat and tidy. But barfing, let her fly. I don't get it. Consequently, I've got a big barf smeared carpet floor cleanup coming. Now, right, I was going to ask the all-knowing, here we are, let me just,
Hey, Jim.
okay, I remember what I was going to ask. I'm working on an old radio and I'm looking at the antenna system, and it's suggesting that we connect the counterpoise to A3. What is a counterpoise in this case?
A counterpoise is basically a system of wires or a metal surface placed at the base of an antenna to help with grounding. It balances the antenna system to improve its efficiency. In simple terms, it acts as a substitute for the earth in the antenna system. Does that clear it up?
That's exactly what I thought. Thanks. Oh my God, I said thanks to her. Don't say thanks to a machine, Jim. I'm trying to prepare myself for a world in which it's hard to tell the difference between machines and people, and I want to treat people like people, and I want to treat machines like machines, and nothing more. And I don't want to get confused about this. I think we're all heading into a confusing future on this, in this regard, and so I'm trying to be rude. I'm rude with can I say her name here? Alexa. I'm rude with Alexa all the time. If you get too rude, they get upset back. By the way, but you know, I'm not apologetic to a machine. That's just not going to happen. Okay, counterpoise. So in some of these radios, they have a little network of wires in the cabinet, sometimes positioned at the top of the cabinet like this. Something that's called a capacitive hat. Could that be the same thing as a counterpoise? So I think of a counterpoise. Have you ever seen Funny Cat? Have you ever seen a Funny Cat video? If you see a Funny Cat video, and here's a car, and there's a cat here, right? The cat's on the hood of the car, and the cat is going to make a jump over here. And when he goes to make a jump, instead of ending up there, he ends up down here because his feet slipped off. Bad counterpoise. No, that's not a counterpoise like this. But that's kind of the idea. The idea is you're giving the antenna something to push against. Kinda. That's the way you can think of it. That's why, although I didn't show it, just ignore all this. I'm going to draw another one here. I'm going to draw in the loop antenna now. I'm sorry for my terrible sketching here, but I'm sure you get the point. Transformer, antenna. Now this is sometimes a wire and a ground, but it could also be another loop. I have one behind me. I'll show you in a moment. This would be the loop antenna. This would be a large thing, you know, hanging outside the radio, obviously in your room, or maybe even outside, but probably in the room with you. And this is a small transformer buried, you know, underneath the chassis of the radio. So this is quite a different coil here, and this is not quite how it looks in reality, but I'm just drawing it like this. The thing about a loop antenna, let me draw here's the wire antenna. Just a wire out in your backyard, maybe hanging from a tree here, you know. These are very, very different beasts. This thing, let me put this down so I can use my hands to model this. This antenna is firing a signal into the radio like this. This antenna, the loop antenna, is firing a signal into the radio like this. I mean, you can see how much better this would be. This would be potentially a lot better than this. This can be helped out with the counterpoise. The loop, no, the loop doesn't need a counterpoise. Loop antenna, here it is right here. This is a small loop antenna here. This connection has just two wires coming out of here. Two wires. And they would connect to this transformer. You couldn't, if you had a simple radio where the antenna comes straight into the grid, this kind of antenna probably wouldn't work at all. Or would work very poorly, surprisingly poorly. So these systems are set up for different types of antennas. And that's what I believe was going on here. And I thought it was a loop antenna, wire antenna, but now it's saying no, this is the counterpoise lead. So we're going to look in the cabinet and see if there isn't some kind of wire or something in that cabinet I didn't notice that really should be connected here. Okay, well, let's do that. And then I'll go drink some coffee. Okay, how about a little more light on the topic? So there's nothing in here. There is a wire hanging down, but it's to ground the metal framework on the dial. Oh, you're looking off to the side there. Nothing much to see down here anyway, but there's a wire hanging down. But that's just going to go to the chassis somewhere. That's interesting too. I really haven't paid attention to that, but somewhere it goes onto the chassis. Very likely right on one of these screws here. It could be up here. And you know what? I think it's right here. I think this is it here. Yeah, this will be where the connection's made, right here. So there's a wire inside there that connects the framework, the metal framework for the dial pointer. And if you don't ground it out, then it becomes a isolated floating piece of metal, becomes an antenna in itself, just sitting out here, and can cause difficulties with the radio. It'd be pretty minor, I would think. Or they're following the basic safety rule that every non-current carrying piece of metal should be bonded together. That's a big safety rule that our companies follow. So, what to do here? Well, I think we're set up for experimenting now. There still is a capacitor I have not connected here yet. Because I've been waiting for this moment here. So I have an outdoor antenna, but it's not a wire antenna. It's a powered amplified antenna, and it has a pretty good signal that it sends down to the radio. That's coming here on these clips. It's not appropriate for experimenting with a loop type setup. I have to use a loop. I have another one here. Let me show you this other one. This is one I made when I was in college out of just materials I had, a couple broom handles and whatever wire I had. And I still have it. Here it is. I have dragged this stupid thing with me all the way from when I was in college all the way to here. Unbelievable, eh? So it's tuned. Down here there's a tuning thing, a little variable capacitor to tune it. The way these loop antennas work, they aren't what you might think. That big one I just showed you, or even the small one, you saw on the small red one, you can probably see there's a lot of loops of wire going around like this. And there is. That's the end, and the other end I'm going to bring down here. There's another loop, you can't spot it. It's hard to spot. On this guy, if you kind of look on the inside, you can tell that a couple of these wires on the inside don't look quite the same as the others. There's something slightly different going on with those. So there is another wire. I'm going to I'm going to draw it this way. It loops. On my big antenna I showed you, it loops around once. So it goes all the way around with the other wires, and it comes out like that. So the way this antenna works is kind of interesting. Here we put in the variable capacitor. So I will draw it like this. I guess you're supposed to draw an arrow through it to show it's variable. And you hook it up like that. That's the entire thing. Coil of wire, capacitor. That's the entire thing. Capacitor is sized and the coil is sized to provide you certain tuning in the range that you want the antenna to work with, and it's going to be the broadcast band. This other coil is the pickup coil. This is the one that's hooked up to the radio. So these two wires in this example, they would come up here. And I'm sorry for the mess, but this is this. This thing is this thing. So this is the pickup. So what happens is you tune this, and when you hit the point, this coil will start what's called resonating at the radio frequency, and it literally boosts it right here. There's no power, no batteries, no electronics, just a coil and a variable capacitor. And now with that signal there, you can grab some of it with this loop. You grab a bit of the signal via transformation and send it off to the radio. The key thing about these antennas is the fact that you're tuning this other loop. So on this little loop antenna, there's two loops here, one that has many turns and one that may have one or two turns. And then it has a tuning here, that's the capacitor. You're tuning this outside coil, if I call it an outside coil. And the inside coil is connected to the leads going into the radio. That's how loop antennas work. They are transformers in themselves. Tuned, basically a tuned primary transformer, I guess you could say. Okay. Now we know about a little bit about antennas. We know about the wire antenna. We know about the loop antenna. We know something about the connections here. And it's time to experiment and try this and that and see what works and what doesn't. Maybe we'll encounter a problem with the radio. I think we're encountering mostly problems with my understanding of the radio. I think that's really what we're encountering here. So, okay, great. I'm going to stop for a bit now. Well, I was just leaving my shop. I got another question for the Oracle here. Let me just switch her on. I have another question about a counterpoise. Could a counterpoise really be the antenna? Hello? Well, it says she's listening. I'm listening. Hello? Apparently she's not. She's not listening. Not listening. I think literally what we're running into is situations where their systems are overloaded. Let's try again. Here we go.
Hey Jim, what's new with you today?
I got more questions about counterpoise. In the service manual for the old radio I'm working on, when it mentions counterpoise, is it really talking about an antenna?
Exactly. In radio terms, a counterpoise is part of the antenna system, usually a network of wires or a metal plate that's placed on the ground to serve as a substitute for the earth in antenna systems. It's essential for providing a low resistance path for radio frequency currents and improving the efficiency of the antenna.
Okay, thanks.
No problem, Jim. What?
Oh my God, I thanked her again. You see what's happening? She deserves no thanks. Would you thank your typewriter? Don't thank your typewriter, don't thank that. Okay, now. Counterpoise. So in my world, in the power system world, I'm going to just kill a little bit of white paper here. Picture those big transmission lines running through the countryside, right? And I'm just going to draw the towers like this. So you have these towers. And you have, of course, the high voltage lines running across them. What can be done is a counterpoise can be installed where a wire is run underground between the towers. Like that. And that's called the counterpoise. That's what we call the counterpoise. Basically a grounding wire, or in this case running underneath the overhead wires. Incidentally, there's another wire, in many cases runs right on the top here. It's a hard one to see. It's called the sky wire. It's a lightning wire. It may or may not be there. It just depends upon how they've done things. So counterpoise. It's a very different thing from what... It's got a ground terminal. Counterpoise. Let me look at this schematic again here. Should I got it on paper here? No, I don't. Okay, let's take a look at the schematic again here. Okay, so she's saying this blue wire is a counterpoise. Oh my gosh, sure. Yeah, this answers a lot of questions. I've been wondering, if you hook an antenna to this, what are you doing hooking a capacitor to the chassis down here? If you hook an antenna to this, what good is it feeding a signal through these transformers? It's not. So I've been wondering this the whole time. Now I realize not an antenna connection at all. Now, why would you need a counterpoise as opposed to just grounding it? So this symbol means attached to the chassis. Maybe this means attached to the earth. Oh, wait a minute, here we are, let's read this. Twisted pair transmission line terminals A1, A2 on the terminal board to rear of the chassis. The RCA Victor Master Antenna Kit. Well, that's not helping us at all. Connect the counterpoise to A3 that came with the antenna kit. Terminal G may be connected to ground, but this connection is not necessary for correct operation. So when people are out buying radios, they would say to the radio sales guy, do I have to stick a ground rod in for that radio? And if he said yes, they'd say, you show us another radio, I don't want to do a ground rod. Ground rods are a hassle. And so if the manufacturers could offer radios that do not require a ground rod, they sell them. And so that's what's going on here. My own experience with doing this, and I've done very little with actual rods in the earth type grounding, is, try different things and see what happens, and that's about it in terms of ground connections. And here in North America, the word ground is thrown around in electrical systems left and right, and it's really poorly done here in North America. A lot of engineers don't quite follow what grounding really is, and so anyway, in Britain they like to use the term earth, which is much more explanatory than ground, because they'd say this is a ground connection here, but it's to the chassis. It's a chassis connection. There are actually two grounding symbols, but back at this point they only used this one here. Later they used a different symbol for the chassis connections from the ground connection. This would become an earth connection symbol later, much later in schematics. Talking a lot because I don't know what to do. That's what's happening here. Well, let's mess around. Well, what that would amount to then is there's really, and look, they call this A also. So G for ground, A for antenna, A for antenna, A for counterpoise, antenna. Connect the counterpoise. Well, what's over here? There's more. I haven't read it all. Noise reducing adjustment. After the RCA Victor Master Antenna Kit is connected, tune the receiver to a point near 900 where no station's heard. Turn volume control clockwise till noise is heard. If no noise of a regular character is audible, start any brush-type motor-driven appliance, such as a vacuum cleaner, electric razor, or refrigerator, but do not bring it too near the receiver. This will generate noise as a continuous crackling or buzz. Adjust C1. There it is. Adjust C1 to a point where this noise is reduced to a minimum. Oh my gosh. Okay, and C1 was here. I don't know what to think. Experimentation is the only way through this, for sure. Okay, coffee time. My mouth is as dry as a desert. And I was in here talking to myself. I'm just looking at my cat. Thought, I gotta share. And look at him. Hey, what are you doing? Yeah. What a cat. Look at that guy. The most handsome cat in North America here. Okay, been a little bit distracted here this morning, so we want to turn on the radio, set it to broadcast band, start with the outdoor antenna that we're familiar with, try varying connections here with the outdoor antenna, bearing in mind it's not a wire and it's not a loop antenna, it's a amplified antenna. So what happens with that antenna is not necessarily indicative of what would happen if we just put a piece of wire on the radio or anything like that. So, and generally it's a very good antenna. So let's start here. Here we go. Just everything ready? I think so. Yeah, let's see if this works today. So make sure I'm on the broadcast band. Yes. And volume up a bit. Let me tip this up just a touch here. low voltage. Let's go for the... So a couple ways to judge how strong the radio is. One is just by the volume. If I just keep my hand off the volume control, just leave it set, and we compare different antennas, we just listen to the different volume, which is probably okay. Another way would be to measure the AVC voltage, but I don't have my clip lead in anymore to do that. I could pick the AVC off the grids here, but I think we'll just see if we just get along with the way things are. Okay, radio must be warmed up. Let me make sure it's tuned. This is a strong station, so it's a good one to work with. So I'm going to leave the volume alone now. And I'm just going to move the antenna connections around. Take the ground off to start.
It's one of the most prominent cities in North America.
I would imagine that connecting here or connecting here is the same thing.
We've got a lot going on in this city sports-wise. There's only so much of it to go around, and unfortunately some of these teams and leagues
Certainly seems that way. Connecting to the supposed
take a hit. That's not to say it doesn't play in other markets.
counterpoise.
You go to Saskatchewan, you go to Winnipeg.
Sounds about the same, doesn't it?
These markets who might be a bit watered down in Toronto, that's talking.
Any one of them sounds the same. Now I thought this shortwave connection was kind of non-functional, but it sure seems to be.
Sure, well now...
Okay, let's do the same thing but attaching the ground. I'm going to put this on the shortwave antenna.
It's tough. It's a crowded market, and in a big city like this...
Put it on the counterpoise. Ground.
We gave you that, but I've really got nothing else to say about Argo's attendance or OHL
So
attendance.
it improves the, I think it improves it. The volume may drop, but I think the signal to noise ratio is better. The noise has gone down more.
Thank you for the text. Always great to hear from you. Brian in Toronto says, gentlemen,
Seems like you can't do anything wrong here. That's what it seems like.
yes, you have the money.
Hook your antenna any way you want.
Save them. I bring this up in relation to Marner, Bichette, and the Jays. The team is spent on Vlad. Bichette, as we know it, is a soon-to-be free agent. As bad as he was, could be.
Of course, that last one is the ground. We're just grounding the antenna away. Okay, so we've got an idea now what we can do with a good signal coming from a good antenna. Now, what happens with this loop? So I am going to assume the loop is attached, to start with anyway, between the two black pins. I'm just going to... So at this point, the loop is working as a bunch of wire. There's no loop effect. This is not tuned. It's just picking stuff up. This gives it an indication of how sensitive this radio is. It's pretty sensitive. I'll hook up the other wire. Now, I was expecting a much deeper drop in the volume when I did that. Okay, we're going to tune the antenna here. No tuning effect. It's almost... Oh my God, I'm a better antenna. That's pretty bad performance. No tuning effect, which is kind of weird. So I believe this antenna has a very, very low impedance being presented to the radio, and the radio may be designed for a high impedance antenna. We don't know. They talked about that special antenna that they offered with it. Look, this doesn't make any difference at all. Once again, I'm a better antenna than the loop here. I'm going to put this on the ground. Now that's more like what I would expect. The radio would go quiet. Now we'll see if we can... I'm going to leave the volume as it is, but listen carefully. It should be down in this area here. You might not be able to see it, but there's a little marker on here right where my finger is. Okay, I'm going to turn the volume up. Just make a note of where it is. Okay, we can hear the hiss now. No tuning in this antenna. something wrong with this antenna? I have another. I'm going to use my own personal loop antenna. My own personal. The one I built. Let's switch to that. This is this great big one here. So the way this one is, remember I was explaining that these loop antennas, you have a bunch of wire looped around the antenna, and then it's tuned against a capacitor. And then you have another wire, a pickup wire. This is the pickup wire here, and this is the bundle that is tuned by the capacitor. This pickup wire simply goes to the cable that's now running over by the radio. So it's very simple. I built this, like I mentioned, with what I had at the time. I had this much wire, I had these poles, and I was in my dorm room, basically, in my small apartment when I was going to college. I lived in a student co-op. I lived in the largest student co-op in North America, a place called Neil Wyzik, which you may have heard of, just maybe, and in downtown Toronto. And that's where I made this antenna. I have lots of other stories, but I won't go into them. Lots of wild stories there. So we got to hook this guy up here to the antenna. Okay, so let's go back over here. Antenna lead. Oop, I need a coupler. Knock that over. Just getting one of these guys. Oh, what's with my camera? My camera is just stalled. I don't know what goes on. I don't know why it does this, but I just reset it and it's back to normal. Okay, so I'm just getting a connector here. This is the antenna. This is the radio. Seems like when I bang this camera, just bump it, give it a bit of a shock, it seems to go offline. I don't know why. Okay, so we're now hooked up to the big loop antenna. No, we're not. No, we're not. Judging by the behavior of this radio, it's going to work fairly good just with a piece of wire, even. But generally, the loop antennas, there you are again. So I just bumped the camera and it stalled. I think maybe that's the wire going in the back of it, but my investigations have revealed no reason why it would just keep stalling like that. But anyway, we're working now. Connect it up. Okay, again, we're going to do, now there's a lot more wire on that big one behind me, so just hooking up one of these will probably bring the radio to life. I'll hook up the second one. I would have expected it to drop when I connected it. So we got problems with this antenna too. I'm going to turn the volume down. So this is where the volume was when we started. About there. Let's see what happens with this antenna now. Come with me. The camera's already stopped. Must be the wire in here. I'll get it going here in a second. As soon as I get the camera in place. Wow, that's really quite annoying. It's not something I was expecting. Okay, it's not quite what we want to look at. Yeah, it is actually. So, okay. Antenna here. Let's try tuning it. I have an auxiliary capacitor. Absolutely no response. I may have to switch to testing these antennas because they don't seem to work. Let me change the connection here on the radio. That's more what I'm after. I'm going to turn the volume up.
Until June 30th, enjoy a $25,000 cash offer. A bold step toward
Because the signal level has dropped.
$25,000
But the thing is, it's noise to signal ratio that's really important. And if you notice, the noise is gone. So I'll tune this now. We'll see what happens now. Fade out. Okay, auxiliary capacitor. There we are. So right in here. Antenna's tuned now. It's a. Let me turn it down. This antenna is directional, so I'm going to rotate it, and we'll see what happens here. Oh, there must be a wire loose on this. Ah!
137 for Rogers Center today. Finale of the three-game series with the Chicago White Sox, who once again, after an historically bad...
Okay, see, signal is faded out.
Friday night, 7-1. Blue Jays answered with a 7-1 win of their own in Game 2. Jays looking for the...
I know from experience, when the loop is aimed this way, I get maximum signals from Toronto stations like we're listening to. So there's something weird happening here. I'm not connecting it. I'm not connecting it to the radio the way I would imagine it should be connected. So I wonder if they set this up. Looking at now. I wonder if they set this radio up for that special antenna that they're selling. And you know, to make a special antenna work really well, you'd have to have a special radio designed for the special antenna. So perhaps with just regular antennas like what I'm trying to use, we're not going to get the best response out of this radio, or I don't understand what they're trying to do, and I never did fully understand. Still don't have that capacitor installed. Would that change all this? Did somebody scream yes? Okay, so I'm going to stop for a while. We're going to put the capacitor in. You know what I got? I got a decade box here. So I'll go down to 0.0001. That's pretty low. Why don't we try the decade box? Let me try it right now.
That's how we talked to our friend Maury Brown, senior contributor with Forbes, talks some MLB. Maury, thanks very much for being with us. So many stories to talk about as we get close to the trade deadline. Maybe we'll do a little speculating later, Maury, but I got to ask you about Devers, the Red
Just
Sox,
keeps getting better.
getting his revenge.
This should go on the chassis.
The way that all unfolded, because Maury, we're having a hard time here in Toronto trying to figure out what exactly is the game plan for the Boston Red Sox, Maury.
Well, that's I think the question.
So we're going to go very small and then very big.
And you know,
Very small,
it's so odd to watch them because
and then
for
we'll
the
very
longest
big.
time they were viewed as the gold standard, right? And now over the course of a few seasons, they've really just plummeted in terms of their decision-making process.
Capacitor that was in there was a
I can't fault Devers in this thing.
.005.
I really can't. I mean, you can talk about,
I think it's up
hey,
here.
you know, I'm a team player and put me wherever, but it does become difficult when you have a guy like that. You're moving him around. You really, you know, haven't really settled in
Seem a
on
little
where
better.
he's going to be. And after a while, of course, the player goes, I just want to get out of here. But if I look at the situation, we can start all the way with the bets, and then you look at this, and it just
Doesn't seem to matter where I set this. Hooking this box up improves it.
They got that first home run as a Giant, and
The way it's improving it is I can hear the noise level dropping each time I hook the box up. The noise level drops. What's that proving? And when I just have one lead to the box, it seems to be better. So I need to experiment with a little capacitor and tight in like this. And didn't I lose track of the capacitor I was using? I thought I did. This is a 15, I think. Let me just take a peek at the schematic here. It's about 15. Okay, so this is the capacitor I was going to use. Let's see what I can do. I can just ground it here and touch it there. Let's turn it up.
A financial move, but we know it was, and we know what happened behind the scenes with Devers. But for him to say you know, we're going to be a better baseball team because of this. Yet he's DFAing one of the guys, or not DFAing, I should say, optioning one of the guys that he got in the trade. Like, it's just really.
I think it's slightly louder.
It really just goes to show this disconnect
Now,
between ownership and fans.
I don't think we're finished playing around with the broadcast band in the long run. Incidentally, the noise came in just now because I re-aimed the other antenna. Let me aim it back. Yeah, don't know why this one didn't work the same. Let's go back to this one. And then we're going to play around with the shortwave a bit. See what we can figure out from that. So it looks like the best way to do this is there and then to the chassis. First of all, it's much quieter, right? Because this antenna just doesn't produce as much juice for the radio to work with. So I'm going to turn it up. And you can hear background hiss. Now we'll try tuning this guy here.
Dazzle initially, and then, you know, players figure them out. They get enough.
Okay, and then direction.
They start to figure guys out. But in some of
Ooh.
the guys from
There's
last
definitely
season
something wrong
who
here.
again are leading the league.
That's why it didn't. I need a new cord. I need a new cord.
There's a good chance that these young guys are going to make some hay. And you start to see it when they get called up.
Weaker like this.
These opportunities.
Stronger like
and
that.
Right now, they're going to get a feel for where things are at. Normally, a lot of times you see call-ups happen with
And that's
teams
hooked up
that are not in a position
with the connection to the chassis.
stuff at the trade
If I put this on where I think it's supposed to go, we don't get a very good response. Now tuning, can't tune anymore. I don't get it. It's
One of the key things that you're starting to
quite
see
clear that
around the league.
a superior performance comes when you connect a loop antenna between either of these black terminals and the ground terminal, or the chassis terminal there.
But the standard by which we're starting to see
Okay.
the ability to scout and look at the analytics of players that are coming up.
So what if we hook up a counterpoise now? That makes sense.
There's always
So let's think about this, counterpoise. So you're probably familiar with a dipole antenna, right? So you have one pole and you have another pole, two wires sticking out, and the cable's coming up here and connecting one connection here, one connection here, and that's your dipole antenna. Very common. You use them all over the place. FM antennas look roughly this size, a little bit bigger than this FM antenna. You can turn them this way. And then you can take one element of it, the lower one, jam it down in the ground. But you don't want to jam it all the way down in the ground, because this would still work. You want it up high in the air. You can get the same sort of effect of jamming it in the ground by raising this up in the air and then putting this like this and putting out a bunch of them in the air. You've probably seen antennas like this. Sometimes these droop, sometimes they're out like that. The length is critical, and all that kind of stuff. So it's all kinds of weird. So this is kind of a counterpoise. You shove it in the ground, or you can have this antenna sitting on the ground, and then you have a whole bunch of wires coming out through your lawn, literally in the earth, just barely buried at all. And they don't even have to be buried, actually. Just shove them down in the grass low enough you don't cut them with your lawnmower, and you'd have maybe a dozen going out in different directions. That's a counterpoise. So in my mind, all these things are giving the antenna something to push against. I'm thinking about transmitting, because it's a little easier to understand this stuff when you think about transmitting. And again, coming back to the cat trying to jump off the slippery car hood, his feet slip, he can't get any power. Same thing with transmitting with an antenna with no counterpoise or no proper whatevers. Okay, not to get into that too much, but antennas are really it's easy to read the theory. It's hard to put it in practice. For instance, I live in a house with a yard, so do lots of people. The yard is a certain shape, the trees are in a certain place, the wires can go a certain area, the cable can get to some spots and not others. So it's a very compromised situation. You cannot put up an ideal antenna. So you got to put up a compromised antenna if you're going to try a wire antenna outside. Or the alternative for AM radio is a loop antenna like this, which is a good alternative. And these little transistor radios, of which I don't have any in here right now, but if I did, I would hold it in my hand and I would tell you there's a loop antenna inside this little transistor radio. They all have a loop antenna inside. Tiny little loop antenna, which makes them directional. Okay, what is left to try here with this antenna? I was going to hang something off this counterpoise. I was going to hang a long chunk of wire off the counterpoise and just see what it does. And I can use any chunk at all. So I am going to use, believe it or not, the other antenna. I'll just use one connection, and then the antenna, my college antenna, just becomes a bunch of wire. I'll hook it up to the counterpoise and we'll hear what happens.
The Rays have been able to do, and try and do something, coming back again to our conversation about the Red Sox. They shouldn't be, hanging around at the bottom of the standings like they're like.
You gotta be careful now because it might get louder, but you hear the noise come in?
You could argue the Tigers, like you said, you could argue the Yankees, but on the flip side, multiple things can be true. It's up for the taking for really
Is something more going on? Is the radio tuning a bit?
Around 500, and it's the better, better than half the American League is pretty much still in this thing. All because, there's so much uncertainty, and where teams are going to go. You figure a lot of teams are going to want to go for it because they figure they have a chance.
Counterpoise.
The National League, though, Maury, it's loaded. I mean, we knew coming into this season that there would be 3 teams, that was before absolutely stunk. Like, there are a lot of quality teams in the National League. It's looking like the bloodbath this year.
So loop antennas are particularly impervious to noise, which is why you like using them. They may give a weaker radio signal, but they're much less noise, mostly because of their low impedance. We should go to the other end of the band and see what's going on. Why not? I could let the motor do this. Okay, there's that weird stuff again. Any station. Oh, I'm on a loop antenna here. Look at how sharp the tuning is now on this antenna. I'm going to try to pick up a station at 1580. Something there. Any station will do. Can't hear it. Can hear it. I'm going to switch to the outdoor antenna. Let's see what we get out of that. At this point, I'm just playing around here, This is what I like to do. All this crazy messing around. That's what I do all day with my own radios. So we're hooking up. Take this antenna off. We will not touch the volume. And we'll see if we can hear that same station. First, the live part. Don't hear it, and we'll ground this. There it is again, almost the same as this antenna. This one might have been doing a little better. And since we're doing antenna stuff, let's go on my antenna here. So right now we're listening to an outdoor mini whip antenna. I'm going to switch to my loop antenna behind me. Here's not. Oh. Too many loose connections. That's a little better. Yeah, playing around like this, with old radios and doing stuff like this, you're constantly dealing with bugaboos and weird stuff happening. And so you gotta be okay. Let's put. What am I doing? I'm doing the wrong thing here. I'm about to connect. Right, think, man. This here wasn't what I need. Okay, on to the loop antenna, big one behind me. Now it's not tuned, so we're going to tune it. See what happens. I probably need the auxiliary capacitor. So based on the accent and based on what they're talking about, this is an American AM station, probably in Michigan, could be in New York, something like that. What are we finding out here? So what we found out is to get the best out of the connections here, it seems as if you need to connect onto the chassis ground, which is this red connector. I'm just going around behind it on a wire with the clip. And either one of these two, I didn't do the capacitor thing again. But we're going to do shortwave. What time is it? Let me get late, 11 something. I'm having too much fun to stop here. Let's play with the capacitor again. If it's making a difference, it's so minor we can't even tell. I didn't have this very loud either. Let's put it again. There we go. It adds noise, that's about all. Okay, let's go shortwave now. This time of day, there isn't a lot of shortwave to hear. So the first band is the 49 meter band, 6 megahertz. Not even worth checking. I'm going to go up, I'm going to go right to the top. 19 meter band, this is 15 megahertz. It's a very high frequency. No hope of the loop antenna helping out with this. The loop antenna just can't, it's really just low frequency broadcast band stuff. I'm going to go on the outdoor antenna here. Okay, turn up a little bit. Turn up a little more. So chances are we're not going to pick up a station, but let's find out. Here we go. Start right at the top. There we are. We're at the top now. It doesn't. Oh. Not a station. It's actually very pleasant to tune this with the motor hooked up. The drag and momentum is not that, it's not upsetting. So we didn't pick up a single station there. Lots of noise though, I'm pretty sure it's working. Shortwave has been crappy for quite a while here. Let's go next band down. And we're starting at the low end of it. Might get a station here. I hope so. May not be because of the radio. The circumstances for shortwave is poor. It's the wrong time of day. Everything's against us here. Okay, so we're going all the way on that band, nothing. Okay, we're going to go down. No, that's up. Ooh, that's got a little more volume. This is a 9 megahertz band. Might get something here. I just need one station. Give me one. Nobody. Is it the radio? Is it the antenna? Is it the conditions? This is what happens with shortwave radio. You never know what the reason is. You're not getting anything. Well, another radio would be good. Let's just check another radio here. Okay, well, I discovered a serious problem with my in-house antenna here, my outdoor in-house antenna, and I've corrected it now. And I'm going to turn the sound on here.
Or is it more than Dr. Clark's business is heating up?
So,
See my help. How will I find time to see all of them? They need to hire a scheduler.
that's
I need indeed. Indeed you do.
that's about as good as it came out of the other radio, the old radio. So perhaps the antenna was working. You know, it's a hit and miss thing. It was a connector that was hit and miss, which I removed from the chain that the antenna signal is going through to get stable response. Let's just zoom up here and listen to a few more stations.
25 escapes start from just $79 a week.
Don't stress too much.
640,
Degrees.
680, 710. This is St. Catharines, but we're not getting it.
All aspects of life.
740 Toronto with interference.
Like that.
Then we want to jump up to 1580. So it's there, but with interference. 13, 14, 30. Can't let music go. Okay, so this is working normally now. I want to try to, let's go back to the camera here. This is going to be a monstrously long video. Okay, so antenna's working, but as soon as I start fiddling with it, for all I know it's going to stop, although I have a better connector here. Better connector. I really need to do this a little bit better. Let's try this. What was buzzing there? Something's vibrating. Okay, the antenna connector is here. So that's a reliable connection. Turn the radio back on. So we are connected to the outdoor antenna. Let me get this right out of here. So we're not confused. This connector has some kind of wonkiness to it. It was causing trouble. Okay, so we're still on shortwave. Come with me. I meant to look on the SDR at the shortwave situation. Let's use this radio. We'll go through it again. We'll go to the top. Top, not the bottom, the top. So this is a 15 megahertz band. What are you doing there, Bert? Okay, nothing at all. Next band. I'd just love to get one station. If I could get one station, that would be great. Nope. Down another level. Careful, Bert. Nothing. Oh, no wonder. Going the wrong way. Nothing. Okay, we're going to have to look on the SDR and find out for sure what's happening here. So let me switch this back to the SDR here. Okay, here comes the SDR. First, look at this cat. Look what this cat is. Oh, here he comes again. Okay, we're gonna shut off the radio here because I can't keep an eye on you. I'm gonna pick you up. And he's purring. He's looking around to see what kind of trouble he can get into. When you pick them up, you know, you're holding them in a place they can't get to themselves, so they get a new view. Wherever you carry them, they want to use the view to check everything out. Down you go. Same as us, doing the same thing we would do. Okay, let's take a look at the SDR now. Okay, so this is a broadcast band, but we really want to go up to a shortwave band, so we're going to go right up to right away 15. Okay, and so this is the shortwave band here. We see a station way out here. 15770. Not very strong. This is here every day, but this is out of the range of the radio on my bench. There's another signal, 15500. Let me look. Okay. Radio. 15. No, doesn't go that high. You see that what happened here is the shortwave band started out fairly small, and then they got expanded because there were so many broadcasters back in the 50s and that. And the expansion came after the radio on my bench was built. So the radio on my bench can't receive the expansion, the expanded signals, which is basically all the way from about here up to here. This is all expansion. So we have to find something in here. There's nothing. So we'll go down to, this is a European shortwave band, but it's not on the radio. So here's a signal though, I think. Let's see. By European, I mean, we don't use this in North America, but no, I don't know what that is. So this signal, as weak as it is an American signal. I'm pretty sure coming from an American transmitter in the States. What it's doing on the European band, my only guess is they're trying to transmit to Europe, and that could be why it's weak here. Their antennas and everything's aimed at Europe, and the conditions are such that they can hit Europe at this time of day. This would be, what, dinner time in Europe? No, wouldn't be dinner time yet. It'd be later afternoon in Europe. Of course, if we go further into Europe, it'd be a little later yet. So, you know, you got to realize that if one part of the world is broadcasting to another part of the world, like it used to be so common, that usually the transmitter's in a very different time zone from the receiver. And okay, let's go down to the next band, and again, there's something up here. I don't know what this is. What is this? Huh. Well, that seems to be out of band. It's beyond the end of this marker. But it's another American religious broadcast, religio-politico cultural, I don't know what broadcast is going on down there anymore. Okay. And nothing here, and there won't be, I doubt there'll be anything here to here. Great, maybe this thing right here. Maybe this guy. If that is a shortwave signal, it's just not strong enough for us to hear. So, you know, wrong time of day to be doing this. And the bands are restricted on the radio on my bench. At night, there'll be stuff for this guy to pick up, especially on the lowest band, the 49 meter band. You should be able to pick stuff up. Okay, I think that's going to be it for today. We've gone way long. Let me flip back to the cameras here. Yeah, I've gone way long. I'm pretty sure I've got a ridiculous amount of video to post. So next thing for this radio now, I think we understand the antenna as much as we're going to. The capacitor here is having a minimal effect, but I'll probably install it. And it's back in the cabin. It's back in the cabinet tomorrow. Tomorrow we'll try to put it in the cabinet and never take it out again. That would be the plan. Thanks a lot for watching. It's been a long series, been a long journey, but I think we're right at the end now. See ya.